In this video, we are going to do a simple example where we use elementary row operations with matrices to solve this system of equations. So let's go ahead and say solution here. And of course, we have the system 2x plus y equals 2. And then the second equation is x minus y equals 0. So the first thing we do, what do we need to do? We need to first put, or maybe say write the system as an augmented matrix, okay? So the first thing we're going to do is say augmented matrix form is 2, 1, 2, 1, negative 1, 0. And there's our partition line. So there we go, okay? Easy enough. Now, the next thing we want to do is we need to apply elementary row operations, okay? So now we're going to say apply elementary row operations to create cancellations on the right side of the partition line. Okay, so there's a few good ways of doing this. Now, I'm going to tell you what I think is the most convenient thing to do. Okay, so let's go ahead. I'm going to write this in red to show you what is usually the most efficient way of tackling these. Okay, the most efficient way is to eliminate, and I'm butchering that spelling, try again, eliminate values in what's called the lower left triangle, okay? So essentially what we want to do is we want to create a 0 in this entry somehow, okay? Eliminate values in the lower left triangle. Now, our lower left triangle for this problem is just one number, okay? So that's usually the smoothest thing to do at first, okay? So here's what I'm going to do. As you know, I also like to avoid fractions, okay? So I'm going to do this while trying to avoid fractions. So watch what I'm going to do. I'm going to rewrite this matrix 2, 1, 2, 1, negative 1, 0. And I'm going to perform an elementary row operation. I'm going to say interchange row 1 and row 2. Oh, having trouble writing. There we go. And so I'm going to rewrite this like the following. I've interchanged row 1 and row 2. Okay? Now, so now, you know, row 1 has become the new row 2, and row 2 has become the new row 1. Now, the next thing I'm going to do is I'm going to say negative 2 row 1 plus row 2 to change row 2. Now, because I first interchanged row 1 and row 2, you know what I did? I have now avoided having to use fractions, and I can cancel this lower left triangular entry, okay? So what happens when I perform this elementary row operation, okay? Am I changing row 1? No. Row 1 at this step is remaining as it is, okay? I'm using row 1 to change row 2, okay? So when I say negative 2 row 1, what does that do to this entry? It makes it negative 2, and then I add that to row 2, and so what happens here? This becomes 0, okay? And then I say, I'm not done yet. I have to do negative 2 row 1 across the whole thing, right? So what's negative 2 times negative 1 is positive 2. Add that to row 2, and you get a positive 3 here, okay? And then last one, you're on the right of the partition now. -2 times 0 is 0, plus 2 is 2 here, okay? And now look what I have here. This is my new system, my new matrix, okay? So what can I do now? Well, you could stop here. You could, I'm going to put a note here. I'm going to say we can now easily use back substitution. We can easily use back substitution. So what am I going to do? Watch this. I'm going to write this in equation form again, okay? So watch what I get now. Back in equation form, I now have x minus y equals 0, and I have 3y equals 2, okay? Remember, these still represent coefficients of variables on the left of the partition, and the right of the partition represents constants on the right of an equal sign. So looking at this system, what do I clearly have? Y equals 2/3, and then I can substitute that into the first equation and say x minus 2/3 equals 0, and then of course I get x comma x equals positive 2/3. And so the system is consistent with the solution x equals 2/3 and y equals 2/3. And that is the end of this example.